Let's start by reviewing the measures of dispersion one more time. Let's say that we have a population of 10 people right here. We recorded the high school GPAs of a population of 10 people. This is obviously a really small population, but I'm just using a small population so that I can more easily do the calculations with you. We can start by making a column of deviations, a column of absolute deviations, and a column of squared deviations. Before we can do that, we have to find out what the mean of this small population equals. So let's add up the 10 GPAs that have been recorded from this population of 10 people. So we have a total of 22. I actually wanted it to come out to a total of 20 so that we could get an even number for the mean. So maybe I'll change one of these numbers. I'll make this a 1.5. And then the same person in the sample would also be 1.5. Now the 10 GPAs from the population of 10 people add the 20. Since the total is 20, we can divide 20 by 10, and we get a mean of 2. Now remember, we have to subtract each number by the mean. So we subtract all of these by 2. First one equals negative 0.5. 1.5 minus 2 is negative 0.5. Next one equals 1. I think I forgot to put a 2.0 right here. These are the deviations. I'll just put DEV for short. To save room, I'll write out absolute deviations this way. To get these, you just write the same numbers but leave off all of the negative signs. They're just absolute values. Negative 1 becomes 1. Negative 0.5 becomes 0.5. 1.5 just stays 1.5. I'll just write this for squared deviations. We have to multiply each of these deviations by itself. So the first one would be whatever negative 0.5 times negative 0.5 equals. Next one would be whatever 1 times 1 equals, and then 0 times 0, and then negative 1 times negative 1. We don't have to actually enter the negative signs because negative 0.5 times negative 0.5 equals the same answer as 0.5 times 0.5. So we can just do 0.5 times 0.5, and we get 0.25. Negative 0.5 squared equals 0.25, just like how 0.5 times 0.5 equals 0.25. Either way, it comes out to 0.25. One squared is just 1. 0 squared is 0. It actually doesn't matter if we square each of these deviations here, or if we just square the absolute deviations. For example, if we squared this deviation of negative 0.5, we would get 0.25. But if we instead squared the absolute deviation of 0.5, we would still get 0.25. So technically we're supposed to be squaring the regular deviations, but if we squared the absolute deviations instead, we would get the same answers. Negative 1 times negative 1 is 1. Negative 0.5 times negative 0.5 is 0.25. 1.5 times 1.5 is 2.25. 1 times 1 is 1. And 0 times 0 is 0. Now what can we do? We can't do anything with these numbers. If we tried to add them up, they would add up to 0. We can do something with these numbers. We can add them and then divide by the number of numbers, which would give us the mean of the absolute deviations. Let's see what that would equal. Looks like they add up to 6. And we have to divide by 10 because we have a data set of 10 people and we have 10 numbers in this column right here. So the mean of the absolute deviations would be 6 divided by 10, which equals 0.6. What we just found is something called the mean absolute deviation. It's just the mean of the absolute deviation column. There it is. What if we found the mean of the squared deviations? If we found the mean of the squared deviation column, it would be called the variance. Just adding all of these squared deviations. We get 14 as the total, and then 14 divided by 10 is 1.4. We found a variance of 1.4. Technically, it's called a population variance, since we found it with a population of people. And the square root of the population variance would be a population standard deviation. Oh, sorry, that's the wrong number. Let's see what this equals. We get 1.18 for our population standard deviation. So the mean absolute deviation was just the mean of these absolute deviations over here. We added these and divided the total by 10. The population variance was the total of the squared deviations divided by 10. It's just the mean of the squared deviations. The population standard deviation is the square root of whatever the population variance equals. So if we take the square root of 1.4, we get 1.18, and that's the population standard deviation. What if we wanted to find these same values with a sample of 9 out of the 10 people? We would need to start by finding the mean of the sample. Let's add the data values of the 9 people in the sample and divide the total by 9 to get the sample mean. We still get 18. And then 18 divided by 9 is 2. Sample mean comes out to the same number as the population mean in this case. That won't always happen. If the sample mean came out to a different number, you would have to subtract each of these by that number. For example, if the sample mean came out to 3, we would subtract each of these by 3. We don't automatically use the same mean that we use with the entire population. But since the sample mean did come out to 2, we'll subtract each number by 2. We'll have deviations here. We'll have the absolute deviations here. I have to just make sure I save enough room. And we'll have the squared deviations over here. I'll be right back. I just have to plug in my laptop. Right here, this is meant to say ABS, which would be short for absolute. So ABS, DEV would be absolute deviations. And then this is just deviations, and this is squared deviations. We'll start by subtracting each number by the mean to get the deviations. Okay, sorry about that. I think I got cut off for a second. This one is negative 0.5. This one is 1. one is 0. This is -1. To get the absolute deviations, you just leave off the negative signs. Zero stays 0, -1 becomes 1, -0.5 becomes 0.5. Whenever you have a positive number, it stays positive. When you have 0, it stays 0. And when you have a negative number, it becomes a positive. We now have to get the squared deviations. They're going to be just the first 9 squared deviations that we have in here, because these 9 people are the same 9 people that we have over here. Under here, I'll write that the sample mean equals 2. That's what we found earlier. Sample mean equals 2, that's why we subtracted each number by 2. If we get the mean of the absolute deviations, we'll get the mean absolute deviation of the sample. Before we found the mean absolute deviation of the entire population. So what we would have to do is add these 9 numbers in the absolute deviation column and divide the total by 9, since we have 9 numbers in this column. If we have 9 people, we end up with 9 data values, and then we end up with 9 absolute deviations. So I'll add them right now. And if I add 0, it doesn't change. Now I have to divide the total by 9. And we get 0.5. The mean of the absolute deviations, which is just the total of the 9 numbers divided by 9, comes out to 0.5. The reason why we divided by 9 is because we have 9 numbers. If we add 9 numbers, then we divide the total by 9 to get an average, or a mean. When we were dealing with the entire population, we added the 10's squared deviations and divided the total by 10 to get the mean of the squared deviations. And that ended up being our variance. Our variance was 1.4. If you have a sample instead of an entire population, the variance formula is adjusted, And instead of dividing by the number of squared deviations, you divide by one less than the number of squared deviations. We have 9 squared deviations in here, so we are actually going to add these and divide the total by 8, which is 1 less than 9. And I'll explain why we do that adjustment. Right now I'm just adding the squared deviations. The total is 3.75. You divide by 8 instead of dividing by 9. You divide by 1 less than the number of numbers. We get 0.468, which is roughly 0.47. And it's actually called a sample variance. It's called a sample variance because the data came from a sample and not from an entire population, and also the adjusted formula was used and not the unadjusted formula that would be used within an entire population. And if you take the square root of the sample variance, which we got by adding these squared deviations and dividing the total by 8, you would get a sample standard deviation. So the square root of the sample variance is the sample standard deviation. It comes out to about 0.685. We can round it up to 0.69. So we have the population variance over here and the sample variance over here. The population variance was found by adding these squared deviations. There was 10 of them, and dividing the total by 10, which is the number of numbers. That's how we got the population variance. The sample variance over here was found by adding the 9 squared deviations that we got with our sample of 9 people and dividing the total by 8, which is actually 1 less than 9. We had to use that adjustment since the data came from the sample and not from the entire population of 10 people. So we added the squared deviations and divided the total by 8 and got our sample variance. And then the square root of our sample variance ended up being our sample standard deviation. So the square root of the population variance is the population standard deviation. The square root of the sample variance is the sample standard deviation. So over here, you divide by the number of numbers, you get this, and then you take the square root of the population variance and you get this down here. Over here, you divide by 1 less than the number of numbers, you get this, the sample.